So based on feedback, there are two types of control system: open loop control system and closed loop control system. So open loop control system means in which the feedback is not present. Input is given to controller, controller checks the input. According to input, the plant takes the action, and that action performed by the controller, or the decision taken by the controller is executed by the plant and output is generated. So that output is not controllable. Means what? Though suppose traffic light is a perfect example of this open loop control system. If suppose four lanes are there, lane number one is suppose green light is on. Though all the vehicles are passed and no single vehicle is pending for crossing the signal, still the green light is on. Means feedback is not taken. Whether the output is required or not, it is not checked, and output is generated continuously. Similarly, your toaster. So what the toaster does, suppose if you set 5 minute heating for toaster, then if the toast get burnt, still it hits continuously. Means what is the condition of your toast? It is not checked, and the heating takes place continuously. So this is the open loop control system. This open loop control system does not take feedback from the output, and it continuously generates the output. So it is an open loop control system. So non-automatic iron is also an example of open loop control system. Again, you can say traffic light a very good example of this open loop control system. Then you can say the room heater. Room heater, what it does, it continuously heats the room. Heating takes place in the air, but if suppose sufficient amount of heat is generated inside the room, still it starts heating the room. It does not stop heating. So it is non-automatic. So automatic means what? It checks the output, and according to that, the heating condition is controlled. But it is not the case. Toaster system, then room heater, then electric iron without automation. The old version iron, you can say, in which the light is continuously on and iron is continuously hitting its lower surface. Then traffic controller. जर सपोज खूप साऱ्या गाड्या असतील आणि तरी पण सिग्नल कधी कधी ग्रीनचा रेड होतो, किंवा सगळ्या गाड्या निघून गेल्या तरी पण सिग्नल हा ग्रीनच राहतो. म्हणजे त्याच्यामध्ये फीडबॅक हा घेतला जात नाही, आणि आउटपुट हे जनरेट केलं जातं कंटिन्युअसली विदाउट टेकिंग द फीडबॅक. सो दॅट्स वाय देयर इज अ नेसेसिटी टू जनरेट द क्लोज लूप कंट्रोल सिस्टम. So closed loop control system input is given to this error detector, or you can say this is a summation point. What is the function of summation point? I'll explain later on. Controller takes the input which is generated by summation point or error detector. This controller takes decision. It actuates the plant. Means plant decision is given to plant. According to that, plant takes the action, and output is generated. Whatever output is generated, that output is taken as a feedback. Output is taken as a feedback, and that feedback element generates feedback according to the output, and then error detector makes summation of that input and the current feedback. Say suppose AC is the perfect example of closed loop control system. You have set here input as a 25 degrees Celsius. Input as a 25 degrees Celsius. So AC starts cooling the environmental temperature. But after that, so though it is cooling, after that whatever output is generated, say it is suppose 28 degrees Celsius. So 28 degrees Celsius is taken as a feedback. Then this feedback is given to the error detector. So what error detector does? The input and current feedback both are mixed together, and some error, or say reference signal is generated. Means to the controller, actual input is not going as input. The summation of input and feedback is given to that controller. So that is your error detector. Okay, so error detector generates some reference signal. Again, after some time, this after cooling, when the temperature becomes 26 degrees Celsius, so 26 degrees Celsius feedback is given to this point, and then 26 and current input 25. So 1 degree Celsius error is generated, and according to that, controller takes decision. Plant makes cooling and output is generated. So again cooling takes place. When output becomes 25, then this feedback element 25 is sensed. So input is 25, feedback is 25. So obviously the difference between two will be zero. So zero input is given to controller and AC stops cooling. So this is a perfect AC is the perfect example of closed loop control system. So in this way, this closed loop feedback system works. So if you make the comparison between open loop and closed loop, the most important difference is open loop does not have feedback and closed loop has feedback. Feedback means what? Some reference signal is taken or drawn from the output. जे काय output generated आहे त्याचा थोडासा signal हा आपण generate करतो आणि तो इथे error detector ला देत असतो. Okay. So suppose another example is automatic liquid level control. Automatic liquid level control, what is the level of tank that is sensed? Then from lower tank, the water is pumped into the upper tank, correct? When upper tank gets filled, it is sensed, means feedback is given to the controller. When tanks get filled, the motor stops or motor, you can say the pumping is stopped. So motor is turned off. So it is again one of the examples. Then automatic iron, electric iron, automatic electric iron, not conventional iron, automatic electric iron. If you set some temperature according to the cloth, suppose cloth is woolen, then different temperature is set. Cloth is silk, cotton, different temperature is set. So whatever you can say the different temperature is set. Whatever temperature is set, when it is achieved, then heating stops. You have seen most of the time you have seen that red light is turning on off. So red light is on means what? Heating is taking place. Red light turns off means whatever temperature you have set, that temperature is reached. Okay, then automatic heating stops. Suppose you are riding a bike. While riding the bike, you can say when you are shifting the gears, the feedback is taken that your bike's RPM is very high. So what you do, you increase the gear. When you press the brakes, then you shift down the gear. Like suppose you are walking again. So when you hear sound from any direction from your ear, ear takes the feedback of that sound. Again, you turn your head to that direction. So human being is a perfect example of closed loop control system. Likewise, voltage stabilizer, missile launching system, ship stabilization, closing and opening of gate of an mall, then satellite tracking system, air traffic controller. So all these are the examples of closed loop control system. Okay. So we can check the so we can compare open loop and closed loop control system. So here you can see open loop control system are less accurate because output does not achieved fully. You can say closed loop control systems are more accurate. Feedback is not there in open loop control system. In closed loop system, feedback is present. Open loop control system, small bandwidth is there. Closed loop control system, large bandwidth is there. Open loop system is less stable. Closed loop control system is more stable. Open loop control system is simple and it is of low cost. As feedback is not present, so it is simple. So it is of low cost. In closed loop system, the feedback is present. Obviously, circuitry is complex and it is costly also because sensors are required. Then next is error detector is not required. In closed loop system, error detector is required. In open loop system, the response to the input is very slow. And in closed loop system, whatever input is there, fast response is given by the system to that input. In open loop system, if some disturbance occurs at the input, that disturbance is not controllable. In closed loop system, the disturbance is automatically controlled. कसा control केला जातो? Automatically कसा control होतो? कारण की feedback present होतो. Feedback असल्यामुळे तो disturbance automatic. eliminate होतं. In open loop system, change in the output has no effect on input. आउटपुट मध्ये जर काही चेंज झाला तर इनपुटला काही फरक पडत नाही, कारण की फीडबॅकच नसतो. तेच जर क्लोज लूप सिस्टीम असेल तर आउटपुट मध्ये थोडा चेंज झाला तर त्याचा इनपुटला पुन्हा सेन्स होतो फीडबॅक थ्रू. म्हणजे फीडबॅक चेंज झाला, फीडबॅक चेंज झाल्यामुळे त्या कंट्रोलरला जे जाणारं इनपुट आहे ते पुन्हा चेंज होतं. Okay, so that is your open loop control system and closed loop control system. So again, if you see it clearly, this comparison is very important as per the chapter's point of view, because open loop control system and closed loop system both are important control systems. So open loop control systems are less accurate, closed loop control systems are more accurate. Open loop systems have no feedback, closed loop systems feedbacks are present. आउटपुट मधून जो इनपुटला काही सिग्नल जातो पुन्हा रिव्हर्स, त्याला फीडबॅक म्हणतो आपण. तो इन क्लोज लूप मध्ये फीडबॅक असतो, असा काय महत्वाचं पॉईंट आहे. ओपन लूप मध्ये फीडबॅक नसतो. ओपन लूप सिस्टीम हॅज स्मॉल बँडविड्थ, क्लोज लूप सिस्टीम हॅज दी लार्ज बँडविड्थ. ओपन लूप सिस्टीम आर लेस स्टेबल, क्लोज लूप सिस्टीम्स आर मोर स्टेबल. Open loop systems simple and low cost, closed loop systems are complex and they're costly. Open loop systems error detectors are not required, closed loop systems the error detectors are required. In open loop system slow response, it gives slow response to input. Input जे काही तुम्ही अप्लाय करता त्याला स्लोली रिस्पॉन्स करतो, आणि क्लोज लूप सिस्टम मध्ये त्याला फास्ट रिस्पॉन्स करतो, कारण की फीडबॅक प्रेझेंट असतो. म्हणजे आउटपुट काय आहे, सपोज आउटपुट अप टू द मार्क नसेल तर पुन्हा ते सेन्स होतं, पुन्हा इनपुटला जातं, पुन्हा आउटपुट अचीव करण्यासाठी त्याची पॉवर वाढवली जाते कंट्रोलरची. ओपन लूप सिस्टम मध्ये डिस्टर्बन्स हा कंट्रोल होऊ शकत नाही, क्लोज लूप सिस्टम मध्ये डिस्टर्बन्स ऑटोमॅटिक कंट्रोल होतो. त्याचं रिझन काय आहे, ऑब्व्हियसली क्लोज लूप सिस्टम मध्ये फीडबॅक असल्यामुळे जर आउटपुट मध्ये डिस्टर्बन्स आला तर तो पुन्हा इनपुटला दिला जातो आणि रेक्टिफाय होऊन जातो. तसं इनपुट ओपन लूप सिस्टम मध्ये होत नाही. ओपन लूप सिस्टम मध्ये आउटपुट मध्ये काही चेंज झाला तर इनपुट मध्ये चेंज होत नाही, आणि क्लोज लूप सिस्टम मध्ये आउटपुट मध्ये काही चेंज झाला तर तो इनपुटला रिफ्लेक्ट होतो, कारण की फीडबॅक हा प्रेझेंट असतो. आय होप इट इज क्लिअर ऑल द पॉइंट्स. Is there any doubt?
No, sir.
Any others? Is there any doubt? Other students? We have seen the differences between open loop control system, closed loop control system, because it is very important to learn about open loop and closed loop control system. The whole chapter is based on open loop and closed loop control system. In next lecture, we are going to take the examples, numerical examples. But before that, we'll learn the Laplace transform, transfer function of the control system. Okay, the derivation is there related to that closed loop control system. We have to derive one formula, and that formula is used in this chapter throughout. So that formula is also an important formula. But before going to that point, is there a doubt here?
No, sir.
Okay.